All right, well, welcome everybody. It's a real pleasure to get to talk to a lot of students today, especially some of you younger folks who are hopefully looking to learn a little something about data science and what a career in it might look like. My name is Bill Franks. I've actually been in the analytics and data science space for a long time. I was chief analytics officer for a large public company called Teradata for a number of years. And then was chief analytics officer for a research and advisory firm called the International Institute for Analytics. And just this past fall, I joined Kennesaw State University. So what I thought I'd do for you all today is I'm first going to go through a couple of examples of some neat ways that analytics and data science is getting used in the real world today. And then I'm going to talk to you a little bit about what you should think about if you think this is an area that you might want to get into as you think about graduating from high school, entering college, and then a career. So just to start, a few examples. Analytics and data science are starting to permeate really everything that we come in contact with. So knowing we have some high schoolers on the phone, one of the things your parents probably worry about is you getting in a car accident as a new driver. Well, it wasn't too long ago that when an accident occurred, you'd have to file a claim. You'd wait some period of time for an adjuster to come out in person, look at the car, assess the damage. They'd then fill out a written report and submit it. And at some point in the future, you may get a check. What they're doing today is using deep learning and artificial intelligence to actually run models against a picture of a vehicle. As you can see here, all of that coloration has been added by a model. It can then estimate where the damage is and how bad it might be based on the historical pictures it's been trained on, and come up with an estimate of the damage almost immediately. Then what they're able to do is actually potentially wire you money into your account immediately so you can go start getting your car fixed. They might still send somebody out to assess the car and come up with a final payment, but things can happen very quickly, and it enables you to get your car fixed and get your finances taken care of very quickly. So some really neat analytics that come into play. Now, all of us eat every day, obviously. There's a lot of analytics even happening in areas like farming and agriculture where you wouldn't necessarily expect it. So some of the big companies that offer grain and feed and pesticides, herbicides, etc., now have programs where if you see something in your field, like in this picture here, there's some little gray dots you can see on the leaves, which seem not normal, as well as some holes that have been eaten in it. You send in that picture, and they'll run analytics to come back and tell you exactly what disease and or bug might be bothering you. What they also do, which is neat, they can then match that up with weather patterns. And let's say I have a certain type of fungus on my crops and the weather's blowing south. They then may reach out to those neighbors south of me and say, hey, Bill's got a fungus of XYZ type on his property today that we've identified. The wind's blowing in your direction. You might want to also consider at least watching for this infection or possibly doing a proactive treatment for that. So again, some really neat stuff happening there. In fact, as they plant crops today, they're sending the equipment that both waters, drops seed and drops pesticide, very specific directions down to a few square feet of exactly how much to put down based on the images, which actually makes everything more efficient and saves a lot of resources like water. Now, a lot of kids love sports. A lot of grown-ups do too. Sports analytics has been booming. And one example that I was fascinated by was when I heard someone from the San Francisco Giants talking about the analytics they're doing. And everybody knows for years they've tracked, the speed at which a pitcher might throw a ball. Well, they're now tracking in real time, not just the speed, but the exact path that ball takes in three-dimensional space between the pitcher's hand and the glove or the bat, as well as the direction and speed of the spin. And this has a lot of uses. So if you're doing it during a game, for example, as the pitcher gets tired, you might start to see the spin decreasing a bit, the speed decreasing, et cetera, and it might give you insights into when you might take them out. On the other hand, if you're going to be a batter against that pitcher, what you're able to do is study how their pitches typically flow, and then program one of the machines that pitches balls at you automatically to try and replicate the general speed, spin, and direction of the ball from that pitcher, so you're better able to match up to them. So there's constant feedback loops in analytics where you collect data, you analyze it, you then take action to attempt to influence the future data. And as you all know, there's all sorts of ways that you're able to interact today and both provide data and get analytics back. In the old days, when I was young and in the age that many of you are, we had to watch TV over an antenna from the air. There wasn't yet cable. That came out, I think, when I was probably in late elementary to junior high school. But the point is, the networks like ABC, NBC, Fox would broadcast their shows, but they had no way to know who actually watched those shows or any information on them unless they did surveys and such, which they did. Now, the era of cable allowed the cable company to see who was watching and what they're watching. And now, of course, with streaming services like Netflix and Hulu, they know everything, including when you pause, when you hit replay, when you fast forward, etc. But the producers of a lot of the content at the network side still traditionally haven't had much ability to understand their customers because, for example, a cable provider or streaming service will serve up a show from AMC, but AMC doesn't have access to that data unless they have an arrangement and pay for it. So what companies do now are things like AMC putting out an app where during a live show like The Walking Dead, they'll have a special thing where you can log on to the AMC app. They'll have some chats. They'll have polls. They'll talk about what's happening in the show. And what that enables them to do now is directly interact with the people watching the show and have information on those end consumers of the content, which is something they've never had before. So tons of different interesting ways to collect data. Now, with that comes a lot of risk. Many of you, I think it's required reading in most schools at the high school level to read a book called Big Brother. And the premise of Big Brother is there's a totalitarian future where literally you are monitored 24/7 by Big Brother. That's the head of the government at the time. They have cameras and microphones in your house watching every single thing that you do and listening and analyzing and getting you in trouble. Well, the reality is today we're actually dangerously close to that if we're not careful. A lot of this data that's getting collected has a lot of good uses. There's also a lot of potential for abuse. You've probably seen some of that in the news. But what I want to leave you students with is that no, your parents are absolutely not crazy when they tell you to be very, very careful about how you use technology today, particularly social media. You are, in fact, generating data that will be permanently kept. Even some of these sites that purport to delete the data after a period of time, remember, someone else could have done a screenshot, someone else could have captured the text. There's no guarantee that that information isn't out there permanently. In fact, you should assume it's out there permanently. So I'll just say, as you get into this and you start to work with data, you'll realize the risks that are involved much more than when you're just having fun on a device. So let's get into a little bit about what a career path is about. So you may hear a lot of different terms thrown about other than data science. You may have heard about machine learning. You may have heard about predictive analytics, artificial intelligence, statistical modeling. They're all different terms, but they really get to the same point. They're the same general career path, which is a path where you're going to learn how to work with data, to understand the patterns in the data, to yield an insight that allows someone to take action. In a business environment, that might typically be, who are you going to target with an offer, or how are you going to route delivery trucks, or how are you going to decide which customers get access to certain premium product lines, etc. So there's a lot of different terms out there, but the general umbrella, if you think about data science and analytics, is broad, and there's plenty of opportunity. So don't get confused if you hear different terms. They're really all largely the same thing for all practical purposes in terms of what you need to think about today as a young student. And there used to be no real career path in this, right? When I started out, we were just nerds in the corner. This is from a famous movie called Revenge of the Nerds from years back. I went into this field fully expecting that I'd enjoy it. But even in my first job, my immediate boss wasn't someone with an analytics background. There just weren't people high up in the organizations that had analytical backgrounds because that was a brand new thing. People didn't have that yet. It's much like if you went back, many decades when computers were new. Initially, virtually nobody knew how to use a computer or had used a computer, even in large companies. Of course, today that's changed. What's the exact same with analytics? It's broadened, it's expanded, tools are available. Virtually everybody in a business world, as well as government agencies and so forth, are somehow interacting with and touching data every day. And that requires people like data scientists and analysts to actually prepare that data, analyze it, and feed them the information that they need to make decisions. So that's where this career path is such an awesome one today. It's high demand, high value, and a lot of opportunity for you to really contribute and be challenged. So one thing you're going to have to learn how to do if you really want to become effective in this area is you are going to have to learn how to program. Now, people always ask me, especially students, oh, should I learn this language? Should I learn Python, or should I learn R, or should I learn Java? And what I've always said is it really doesn't matter. There's a certain way of thinking and a certain way of laying out the logic of code. If you learn that, that's going to set you up, and you can always learn another language. The analogy I like to use is that when all of you were little kids, when you were first born as a baby, for example, you didn't know anything about language. You didn't know how to talk. You didn't know what words meant. You didn't even understand the structure of what's a sentence, what's a noun, what's a verb, how do I tie them together? That is an immensely hard thing to learn, the core of language, as it is very hard to learn your first programming language. But think about it. Most of you on this call today, I'm assuming, obviously speak English. You know how to speak English. Let's say I told you had to learn a different language you've never spoken or read before. Well, you have to put some effort, but in your head, you can formulate exactly what you want to say in English. And now you just have to figure out, well, how do I say that same thing in another language like German or Spanish? It's the exact same thing with programming. If you can become a proficient, good programmer in one language, you can transfer those skills to another. So I would say focus on learning how to program and the process of programming, and you'll be set. Now, the interesting thing today is that you can learn programming logic without having to get deep into the syntax. And there's great programs out there I'd suggest that you look at, things like Hour of Code. I believe these screenshots are from Hour of Code a couple years ago. What they have are little tools, and this one here is called Blockly. If you notice, there's little icons to the right of on each side of the screen shots, like move forward, turn left, and then you chain those together. And what you're doing is creating the logic of what you want to happen without worrying about the syntax. So if I'm in a raw programming environment, I have to worry about exactly where do I put a semicolon or a comma, etc. This lets you really focus on that logic, and they're phenomenal tools. And so, of course, this example, Angry Birds, was huge a few years ago. I guarantee you they have some current games and such that have volunteered to allow their imagery to be used. And so what this does is let you not worry about the syntax so much, but really focus on the logic and the flow of what you're doing. So definitely look into programs like that, and it'll enable you to learn how to work with data and how to apply that logic effectively. Now, if you want to be a data scientist, what makes a great data scientist? I have literally an entire hour talk on this I could do, and it's been a chapter in a couple of my books, but I will focus on a few high points for you. First, it's going to take commitment. What you're typically doing in data science is trying to solve problems that were previously not solved, often with data that has not been used for that purpose in the past. And that takes commitment because it's very hard. You've really got to bring to bear a lot of effort, a lot of thinking, and a lot of planning. It actually takes a lot of creativity, and this surprises people. There's a lot of creativity in figuring out how to fix a data problem, how to best get two pieces of data together in an efficient manner that it will scale, etc. And you'd be shocked at how many of the very top analytics and data science people that I know who are theoretically just very, very technical in nature, who, by the way, were also very much a musician, or who do art or some kind of craft on the side. It's very common because creativity is a big part. So don't ignore your creative side as you develop your technical skills. You're going to have some business savvy. By that, what I mean is you can't simply understand the mathematical, statistical theory behind the algorithms that you're doing. You've got to, over time, learn the realities of the business you're working in. Are there certain organizational policies or government regulations, et cetera, that would limit some of the actions that you think you'd like to take from actually being feasible? Then presentation skills. No matter how you get into this field, you're going to come up with results. The way those results add value is to be acted on. In other words, I could uncover a $1 billion opportunity that's worth actually $0 exactly until someone actually takes action to capture some of that $1 billion opportunity. The only way they're going to take that action is if I'm able to present to them effectively what I found and why the opportunity is there and get them to do it. And the last is intuition, which is a little bit of mix of creativity, experience, et cetera. It's you have to get to the point where you've done things enough that you just sort of have a feel for what needs to happen next. Now, there are a variety of roles in data science. There's the building of the models, but there's a lot of others too. And again, I have an entire 45, 50-minute presentation I could do on this topic, but I'll give you a quick one. There's something called a data engineers. If you're really more into the technical side, the system side, the data side, data engineers focus on helping to collect and prepare the data to feed into all of those various models. And that's another career path tied to data science. There's analytic translators. These are roles that are more technical than the typical business person and more business oriented than the typical technical person. In this role, for example, you wouldn't necessarily have to know how to code. You just have to understand the concepts, and you help with the scoping and design of analytics, and you help with figuring out how to deploy them from a business perspective. There's an ability to get involved heavily in the interface and application design around tool sets and web pages and such that make use of analytics. There's operations roles. If you really want to get deep into the computer science and system side of things, optimizing systems, how do you get all the computers to talk to one another? Another great way to do it is through these operations roles where there's now people who are focused heavily on how to make all this happen at scale and keep it running smoothly as analytics and data science get fully automated throughout an organization. And last, there's leadership roles, chief data scientists, chief analytics officers, chief data officers, where you lead the strategy, you lead the design of the organization and what its mission is. So with all that said, one of the most surprising things to many people is that accurate results and solid results don't guarantee success. Now, they're absolutely critical. I would always say you have to have good results. But I argue that at most 50% of the success of any effort or project is having those accurate, solid results, though they're required. The other 50% is in how those results are presented and positioned and how well you can communicate to the people who need to act on it, what they do. And that can't be overemphasized enough. This is something, again, where a lot of technical people tend to underdevelop these skills. You just can't do that. So if you want to become a data scientist, first of all, focus on getting good grades. Obviously, you're going to have to get into a program at a good school. You're going to need some good grades, especially in your math and science. Learn how to program and work with data. I talked about Hour of Code. There's so many different options out there for you to do that today, as well as courses you can take. So make that effort. You do have to develop your social and interpersonal skills. You're going to have to be dealing with people. You're going to have to be presenting with people, working on a big team. You've got to have some of those skills. Just as you develop those skills, as we talked about earlier, listen to your parents and be careful in what you do on social media. Be ready to work very hard. This is not a field for someone who wants to work 9 to 5 every day and go home. There's always challenges and problems to do, but it's very rewarding as well. So if you like it, it's fun to work hard. And last, make sure you take time to learn about the practical implications of the technical work that you may do, because that's really going to be what helps you stand out. And so with that, there's my contact info. I'll thank all of you for coming, and I think I've only got just a few seconds left. Let me see if there's one question down here. Yeah, I think 1 or 2 of these questions might be a little longer than I might have to answer because I'm down to about 20 seconds. But I'll just say, I love the fact that there's so many students coming on to hear about data science, and I do hope that a few years from now, I'll see many of you coming on the job market and maybe coming through the Kennesaw State University programs. We'd love to hear from you. So thank you.